Why do magnets repel is a question you think you know the answer to. No one's answer, including mine, will make you feel better until you figure out why your question is wrong. Let me show you what's wrong. Take out two magnets and line them up with their north poles facing each other. Feel that push, that resistance you can't see in the empty space. You need to know why. So you want me to say that magnets push each other away for the same reason that H and then name something you know? You already know what rubber bands, springs, and two hands pushing against each other are. Now here's the deal. No one knows what it is. H. I'm not being hard to deal with. Don't think I'm hiding behind my complexity. Most people don't want to hear this, but I'm telling you the truth. Magnetic forces are very important. They're at the bottom. You can't put anything else under them to compare them to. To help you understand electromagnetism, please let me use a simpler example. That being said, there is nothing easier. That's like asking me to use something less basic than numbers to explain math. Not possible. H, right now you might be thinking, wait, I've heard explanations. Electrons moving and magnetic fields. Those sound like more in-depth explanations. They are not descriptions. Very clear and precise descriptions. They don't explain why the force exists. They just tell you how it acts. And you need to know the difference between those two things, or we won't be talking about them anymore. I have a question for you. Right now, put your hand on your desk. Sure, go ahead. Do your best. Why can't you get your hand through? That's not right. You should say, because the desk is solid. That's right, since the desk isn't solid. Yes, it is. But that's not an answer, so it's wrong. That's just a different name for what you want to understand. Do it again. Why can't you get your hand through? Since the atoms are close together. Better. Do not stop. The atoms in your hand should be able to pass through the atoms in the desk, right? To be fair, atoms are solid too. Not at all. Don't go. Take a look at this. Atoms don't hold together. An atom is mostly empty space. As big as a football field, an atom's nucleus would be in the middle, shaped like a pea. Eons would look like tiny dots far away from the seats. There is nothing there between them. There is almost no space in your hand. There is almost no stuff on the desk, so why don't they just go through each other? You're beginning to feel uncomfortable, okay? You need to be. The answer is that electrons are pushed apart by electromagnetic force. There is the same charge on the electrons in your hand and on the desk. Charges that are similar push each other away. That is why when you push down, you feel what you call solid, which is made up of trillions of tiny electromagnetic interactions. This question will really bother you. What makes like charges push away? That's impossible for you to answer, right? The only thing that giving it a name does is make it sound better. That doesn't explain anything. As in, why do magnets push away? Because of the force of magnets. That makes no sense. That doesn't give an answer. One of the four main forces in nature is the electromagnetic force. It's not because of something else. It doesn't come from something simpler. It is what it is. Also, no one tells you this. Magnets push apart because of the same force that holds your hand to the desk. The electromagnetic force is the same force, not similar, not analogous, or the same. So why does one seem clear and the other seem unclear? Let me explain. Since you were 6 months old, you've been pushing on solid things. Your brain had stored a huge amount of information by the time you were 2, being rough, grabbing, falling, and hitting the ground. Those experiences changed the way your neurons are wired. They set up habits, expectations, and a whole set of rules that made sense. It feels normal, natural, and clear now when you push on a desk. It's not on your mind. You don't think I should explain it. Magnets, on the other hand, can move through empty space. The gap is clear. A piece of paper can go through. There's nothing there. That doesn't make sense. That doesn't feel right. That seems like it should have a reason. But let me tell you the truth. Things are not weird in the real world, just in your head. When you push on the desk's electrons never touch the electrons in your hand. As far away as a few atomic widths, they don't stick together, but they do. We call it contact, since we can't see how far away it is. We're not really in touch, though. There is no touch. It's electromagnetic force pushing things apart across a gap. With magnets, the space between them is bigger, a centimeter or an inch, so you can see it and feel it. The force is still the same, though. The way it works is the same. The only thing that's different is the size. The mystery you feel is not a mystery in the world of physics. In your mind, it's a mystery. At atomic distances, you're used to electromagnetic repulsion because you've known it all your life. Because it's not something you're used to, electromagnetic repulsion at centimeter distances makes you feel uneasy. That's it. That's the main difference. After reading this, you might be thinking, okay, fine, but surely quantum mechanics explains why the electromagnetic force exists. But it doesn't. Quantum electrodynamics, or the quantum theory of electromagnetism, has been tested more than any other theory in the history of science. We've checked some predictions to 11 decimal places, and they match the theory perfectly. But this is what QED does. It gives you crazy accurate instructions on how to figure out electromagnetic interactions. You can use it to make rules, equations, and predictions. It doesn't, however, give you a deep philosophical explanation for why the electromagnetic force exists. It does a great job of describing the force without trying to explain it away. There isn't anything simpler, so it doesn't round it down to something simpler. I'll use a different example to show you how this works. You want to know why ice floats on water. I can tell you because water is less dense than ice. What makes it less dense? This is because there is more space between the molecules in the molecular structure. Why does it have that shape? Because of the way hydrogen bonds set up when it's cold outside. This is how hydrogen bonds are set up. Why is that? Because of the way electrons in water molecules behave in quantum mechanics. What makes electrons behave that way? This is because of the Pauli exclusion principle and the Schrödinger equation. Why do those math problems hold true? Okay, now you see what's going on at each stage. The answer I'm giving you is more in-depth, but I'm also moving the question down one level. You will eventually reach bedrock, the basic equations and forces. This happens very quickly. That's the only honest answer there. Things like that happen in the universe. We can use math to explain it. We can try it out in a controlled way. It can help us guess what will happen and build technology. There isn't anything more fundamental, though, so we can't use that to explain it. The list of reasons has to come to an end somewhere. This is what's really wrong with your magnet question. When you ask why, you're not really trying to find out something. You want to feel better. You want me to make the connection between the new thing and something you already know so you don't feel so lost. You want a narrative, a story, or a chain of events that leads to something you already know. But because of electromagnetic force, magnets push away from each other. There is also an electromagnetic force because that is a basic property of the universe. There's no story. There is no deeper because all that is left is math and measurements. I know that's not enough now. You must want more. It doesn't matter what you want, though. The world is the way it is. I have a big problem with this question. You treat magnets like they're unique, like they're the only strange thing in a world full of normal things. That is wrong. If you look hard enough, everything is electromagnetic. Why do chemicals mix? Electromagnetic forces move electrons around. How come light bounces off of mirrors? Using electromagnetic fields. How come you can see color, electromagnetic waves hitting your eyes? In what way does your computer work? Electric and magnetic forces move electrons around in circuits. The electromagnetic force is not a strange thing that only happens in magnets. It's everywhere. It's the most important thing in your life. 10 times stronger than before in terms of gravity. Atoms and molecules don't care about it at all. There are strong and weak nuclear forces that are locked up in atomic nuclei, not far enough to change things you can touch. Electromagnetism is everything else, and I mean everything. Right now, your body is held together by the same force that makes magnets push apart, the same force that keeps you from hitting your head on the chair, the same force that lets you read these words. So when you ask me to use electromagnetism to explain magnetic repulsion, you're asking me to use electromagnetism to explain magnetic repulsion. It makes a circle. Not possible. I'm going to try something different. This might be useful. Do you know how to tell someone who can see what blue is? A blue shirt, you show them the sky, you give some examples, but how do you explain blue to someone who has never seen it? You can talk about wavelengths that are about 450 nanometer. You can say where on the spectrum it is between red and green. You can show them all of blue's physics, but none of that really describes the experience, the real bless. They need to see it. There is no easy way out. Magnets are the same. The same goes for electromagnetism. An analogy doesn't give you the feeling. A 5-minute explanation isn't enough to help you understand. You need to use math to solve problems, make calculations, guesses, and then test those guesses. If you work with electromagnetic theory for months or even years, your brain changes in a way that it starts to feel natural and easy to use the equations. Clear, not because they match what you know from everyday life, but because you've built up a new everyday experience in math with how fields behave. After that, magnets won't be so mysterious. You'd expect them to happen because charged particles and fields have that effect. You can't speed up that process, though. You can't skip ahead. To have intuition, you have to earn it. Let me give you something now. The answer in words. Magnetic dipole moments are like little arrows of magnetism that are found in magnets. A permanent magnet is made when many of them are lined up in the same direction. Because of these dipoles, a magnetic field is formed that stores potential energy. It is natural for physical systems to move toward states with less energy. There is a lot of energy when two north poles face each other. The energy drops when you move them apart, so they push away from each other. That's the answer. That's all the way down. You want to know why dipoles make fields, right? I know about charges that move and how electrons spin. You want to know why electrons spin? The Dirac equation and quantum mechanics are things I know and can talk about. You'd like to know why the Dirac equation is right. I can tell you that it makes sense when you put special relativity and quantum mechanics together. You want to know why those ideas are true? They are true because they are true. We know they work because we've tested them 1,000,000 times. That's it. That's the end of the chain. There are some things you need to know about how physics works. Philosophy is not where we start and then figure out the universe. The first thing we do is measure. Patterns stand out to us. Equations are what we use to describe these patterns. We put those equations to the test with new data. We say that we understand something when the equations work and let us guess what will happen that we haven't seen yet. Knowing a lot about physics doesn't mean being philosophically satisfied. It doesn't mean going with your gut. There is a lot of power in that. It means being able to figure things out, guess what will happen, and make technology that works. By that measure, we know more about electromagnetism than almost anything else. Extremely accurate tests are done on quantum electrodynamics. The magnetic moment of an electron can be calculated to 11 decimal places, and the results are always the same. This is what I mean when I say I understand magnets. I know how much force there is between them. I can tell ahead of time how they'll act in different arrangements. I know how to design MRI machines, electric motors, and generators. I can change magnetic fields to focus beams or trap particles. That's really getting it. That's what physics gives us. Not ease or analogies that are already known, but power and control over nature. This answer may not please you. You might not be happy with it, tough. The universe is not required to give you a satisfactory answer. It doesn't have to tell you a story that fits with how you think things should work. To throw rocks, pick fruit, and stay away from dangerous animals on the African savanna, your intuition has changed over time. It didn't change over time so that we could understand quantum fields or how electromagnetic fields talk to atoms. You have two options when physics shows you something that goes against what you think you know, like particles acting like waves, time slowing down at very high speeds, or magnets pushing through empty space. You can say it's not clear and satisfying, and keep looking for better explanations that don't exist. You can also grow your intuition, learn how to do math, take care of the issues, make new mental models based on experiments and equations instead of what you see and do every day. People who study physics do that. Quantum mechanics didn't make sense to any of us at first, but after working with it for a while, it became second nature and started to feel right. It's not because it makes sense. It makes sense because we made it make sense in a mathematical way. This is what I want you to remember. Don't ask why the next time you pick up two magnets and feel them move apart. Find out how. What changes when you move away from the force? In terms of strength, how strong is it? How do I figure it out? How do I use it? There are answers to those questions, answers that are good, clear, and beautiful. The question why, which wants to be boiled down to something more familiar, does not have an answer, not for magnets and not for any important force, because fundamental means just that, the very bottom, nothing below. But people miss the beautiful thing when they can't figure out why. A small set of rules governs how the universe works, as shown by physics. It's the same equations that explain lightning, brainwaves, computer chips, the northern lights, chemical bonds, why stars shine and why atoms stay stable. That's not being able to explain, that's coming together. That means finding a deep structure, a mathematical structure, beneath all the chaos and complexity that nature seems to have. There are simple rules that have very complicated results. That really should blow your mind. Not that magnets can't be broken down into something simpler, but that a lot of things that seem different can all be broken down into the same basic force. You asked me to explain magnets by saying something familiar that they are like, but let me tell you something better. Everything you know is made of magnets. To put it another way, everything is electromagnetic. The same thing. Your desk, your body, the air, light, chemistry, and even life itself are all made up of different ways that electromagnetic waves interact with each other. You are not something separate from the magnets. You're made of the same stuff. So, was it cocky of me to refuse to answer the BBC interviewer? It was honest, though. I could have lied to him to make him feel better. You could say that magnets are like springs, or that magnetic fields are like rubber sheets, or something else that would have made him nod and be happy. He wouldn't have learned anything. I told him the truth instead. The question itself wasn't working right. There is no such thing as the kind of why he wanted. Things are just the way they are at their core. And it's not our job to make them easier to understand. It's how we describe them. People didn't like that answer. They thought it was vague and a failure to communicate. They were wrong, though. There are times when telling someone the truth is the best thing to do. What you think is wrong isn't. That is, you need to change the way you think in order to understand what is going on. That's not being cocky. That shows respect. Know how to treat the truth, respect for the way things really are, and respect for you. Thanks for being able to deal with the truth without needing a safe story. Now take those magnets again. Feel that push you can't see. This is how you should feel. One of the 4 basic forces of nature, the same force that makes chemistry work, the force that makes the stars shine, the same force that holds you together now. That's not a secret. That's wonderful. The fact that we can use equations to describe it, experiments to test it, and technology to build on top of it doesn't mean we didn't explain it well. That's what real understanding looks like.